Next thing we want to look at is domain and range of functions. So just a reminder that the things you really need to watch out for is dividing by 0, right? That's no good. That's not defined. And taking an even root of a negative number. That's no good because it's just not defined, at least not with the real numbers. So watch out for that, watch out for that. So in general, when you have 1 over something, you need that something to not equal 0, right? Because otherwise you'd be dividing by 0. And if you have the square root or the fourth root of something, you need that something to be greater than or equal to 0. Otherwise you would be plugging in a negative into an even root, and that doesn't make sense. So for number 1, it says identify the domain of f of x equals 1 over x. Well, that's just x does not equal 0. And the range is y does not equal 0. This graph just simply looks like this. It's got some asymptotes. Then g of x is equal to 1 over x minus 2 plus 3. Well, that moves f of x to the right 2 and up 3. So the domain and range should change in the same way. So x can now not equal 2. Obviously, that would cause us to divide by 0. And y cannot equal 3 because I've moved it up. So the graph of g of x has been moved over to the right 2 and up 3, like so. And it looks like it has the same shape as f of x. Okay, again, for domain, you need x minus 2 to not equal 0. So then x cannot equal 2 because otherwise x minus 2 would equal 0. And finally, h of x is f of x plus 2 minus 2. So we're plugging in x plus 2 in for x and then subtracting. So that should be 1 over x plus 2 minus 2, since f is 1 over x. And so x cannot equal negative 2, and y cannot equal negative 2, because we moved it to the left 2 and down 2. So to the left 2, this is my vertical asymptote, and down 2, this is my horizontal asymptote, and my graph will look something like that. Okay, so you can see that the transformations, especially the translations in this case, affect the domain and range, but you can also think, well, what can I not plug in here because I'd be dividing by 0. Now 2 gives us the function f of x equals square root x. We already know that the domain of that is x is greater than or equal to 0, and the range is y is greater than or equal to 0. It's really helpful to know that the graph looks like that. If you forget, just plug in some x values like 0, 1 is 1, 4, the square root of 4 is 2, etc. Now for g of x, which is equal to the square root of x minus 5 plus 2, now we've moved f to the right 5 and up 2. So instead of starting at 0, 0, it starts at 1, 2, 3, 4, 5, 1, 2, like that. So it's not hard to see that the domain is now x is greater than or equal to 5, and the range is now y is greater than or equal to 2. But remember that anything that's inside an even root has to be greater than or equal to 0. So x minus 5 has to be greater than or equal to 0, which means that x has to be greater than or equal to 5, which is what we can see from the graph and thinking about the translation. Now for h of x equals negative square root x plus 2, this thing has been moved to the left 2 and reflected across the x-axis. So instead of looking like this, it's moved to the left 2 and then reflected across the x-axis. So it looks like that. So the domain of this is x is greater than or equal to negative 2, and the range is y is less than or equal to 0, because this radical is positive, but when you put a negative out front, it becomes negative. So those are a couple examples of domain and range of functions and how it changes with transformations. Now, if the domain of some function f of x is 0 to 5, and the range, so this is domain, and the range is negative infinity to 0, then if we have negative f of x, the domain is the same because we can still plug in the same x values, but the range is now 0 to infinity because we made all of our negative numbers that we were getting out positive by putting negative out front. if we have f of negative x, now instead of plugging in 0 to 5, we can plug in negative 5 to 0, right? Because we're changing the signs of all of our numbers because I reflected across the x-axis. And our range doesn't change, so it would still be negative infinity to 0, our original range. Now for 3 times f of x, I can still plug in the same value, so it's still 0 to 5. And my range, well, it would be 3 times negative infinity, which is still infinity, and 3 times 0, which is still 0. So even though it's going to be stretched, well, I think it will still be negative infinity to 0. I'm not 100% sure on that, but I'm pretty sure that's true. Now if I have f of x minus 2 plus 3, now my domain has been moved to the right 2, so it should be 2 to 7. And my range has been moved up 3, so that should be negative infinity to 3. And finally, for f of 2x, my x values now I have to divide by 2 so that when I plug them in, they're multiplied by 2 and I get back to this. So this would actually be 0 to 2.5, because if I plug those in, I'm going to get 0 to 5. And then my range is still negative infinity to 0. So you can sort of see how these transformations affect the domain and range. And the final question in this section was, why isn't it interesting to talk about the domain and range of odd power functions and odd root functions? Well, that's because odd power functions look like this, and odd root functions look like this. So their domains and ranges are all real numbers, so it's just kind of boring to talk about.